Good morning, good afternoon, and good evening. Thank you for joining the Go Day on Google Open Source Live. This is an awesome monthly series of sessions led by open source experts from Google and community leaders. We really appreciate the ability to come together digitally and keep the community moving forward. My name is Carmen Ando, and I'm the Go Open Source Strategy Lead at Google, joining you from Ann Arbor, Michigan, near Detroit, enjoying the cool fall weather.
Hi, and I'm Steve Francia, Go's product lead, Google's product lead for the Go programming language. And I'm joining you from Connecticut, which is just north of New York City. And I'm really excited to be part of Google's first Go conference.
We have a really exciting session planned for you today. We're going to start with an intro to Go led by Matt Paring, Go's product marketing manager here at Google, my co-MC Steve, and yours truly. Next, after that, Steve Trout, a technical writer for Go at Google, will walk us through installation and Go basics. The session after that will be Julie Chu and Rebecca Standler, software engineers on the open source and tooling Go subteams at Google. And they'll tell us all about leveling up with Go package discovery and editor tooling. Finally, we'll wrap up with a third Steve of the day, Steve Kaufman from Khan Academy, who will show us an actual use case of how using Go saved Khan Academy time and money.
This is an extremely exciting time to be a part of the Go community and the Go team at Google. We can't wait to share with you what we've been working on. We hope it helps you move forward with your work as well. Now, before we start, there's some housekeeping items. The first is, don't forget to put your questions in the live Q&A. This will be right below the live stream window. And if you're viewing it in full screen, you have to exit full screen to be able to see the live Q&A part. Our sessions today have been pre-recorded to allow for accurate transcripts, and so our speakers can focus on answering your questions live. So don't worry about asking questions. We already recorded the sessions. We're just there to answer the questions for you live. And once we're done, don't forget to join us for the after party on Google Meet. And we will share a link to Google Meet to the after party at the end of the last session. Without further ado, let's start our first talk.
Hello and welcome to Google Open Source Live. We're excited to have you here and to share a few things with you about Go. I'm Matt and I'll be talking a bit about Go as a language and why it's a great fit to build fast, reliable, and efficient software at scale. Then my colleagues Steve and Carmen will cover the most common use cases for the language. So let's get started. So why choose Go? Let's start with the basics, covering the foundation of the language, and give you an idea of what to expect when using Go. At a high level, Go is designed to be simple and reliable in the era of multi-core computing. It's easy to learn and get started with many developers becoming productive in just a few days and sometimes even hours. Go is also a cloud-native language designed to operate at scale. It was built with microservices in mind, and its standard library and performant design make it perfect for large distributed systems. And Go has a thriving ecosystem with a growing set of partners, communities, and tools. Gophers around the world are constantly adding new packages, organizing events to share knowledge, or contributing to the core language. And if you're new to Go, chances are there's a Gopher out there ready and waiting to answer your questions. These three pillars of Go, simplicity, scalability, and community, make working with Go a great experience. So let's take a moment to talk a bit more about the language itself. So what makes Go great? As a language, Go is everything you need, right out of the box or binary. And that starts with its robust standard library. Go's standard library is incredibly comprehensive and of excellent quality. It's extensible and includes packages that cover the basics of almost any project. From building web servers with Go's built-in high-performance HTTP package, to handling files and other programs, to managing encryption with the crypto package. For whatever you're building, chances are there's a package or two in the standard library that will help. Go also helps keep things maintainable with automatic formatting and documentation. And this is in addition to Go's syntax that focuses on readability. Many projects are built solely relying on the standard library without having to look elsewhere for support. And while the standard library is expansive, if your needs aren't met there, there's definitely a solution in the ecosystem. Now let's talk about building with Go. Building with Go is easy. When working with a language, every Go program compiles to a single binary, including any system code required to run it, which keeps things simple as projects progress in complexity. And as they progress, you can leverage Go's built-in concurrency mechanisms or Go routines, which make it really simple to build concurrent programs, all while taking advantage of Go's fantastic memory and CPU management and instant startup times. Additionally, Go's dependency management is tightly integrated and seamless. With modules, which we'll cover a bit more in detail later today, Go helps you keep packages secure and compatible, helping you avoid the diamond dependency problem and dependency hell. And to top it off, Go is supported by the Go team at Google, who work every day to continue to improve the Go experience. From leading our biannual release process, to directly triaging security reports, to working collaboratively with the contributor community to ensure feedback is front and center of the development process. And their work leads to great results for all Go users. Just recently, in the latest release of Go 1.15, we saw a sample of Go programs compile around 20% faster and take around 30% less memory on average for all projects, but especially large distributed projects built in Go. That can lead to a solid reduction in compute costs. And this is just one example of many changes the team has worked on and will continue to work on with the community's help. This kind of performance increase, 15 versions in, is what the team aims for with every major release. And as we continue to improve the functionality, performance, and productivity of Go, we make sure that every Go program, written since the original release of Go 1.0, will compile with newer versions up to our latest release. This is our 1.0 compatibility promise. It's awesome, and it's part of what makes Go so easy to maintain. So let's take a step back and look at the ecosystem, which continues to grow with more developers using Go every day. Just to get a quick sense, we took a look at growth in pull requests of Go programs on GitHub. Over the last 5 years, that amount has nearly tripled, and it continues to grow. Additionally, several surveys cite Go as the #1 language in several areas. Go shows up as the top language that developers want to learn, and also as the top language that developer teams are looking to adopt or migrate to. Go also shows up as the highest paying language, and the language with the most demand from employers, and this comes as more companies are increasingly seeking Go developers. In short, it's a great time to be a Go developer, and a great time to start building with Go. And when it comes to building with Go, many companies around the world use Go and are often sharing their insights with the community. PayPal, Facebook, Microsoft, Mercado Libre, Netflix, and many more companies are using Go. A great example, which you'll hear much more about later today, is Khan Academy, who began migrating their infrastructure from Python to Go and have already begun to see the benefits of doing so. And of course, we use Go here at Google. From the web indexing pipeline that powers Google Search to the backend of Firebase hosting, which powers thousands of websites around the world. We also use Go on teams like Chrome, messaging, and many more. And in line with companies using Go, we're seeing folks choose Go to build software in the cloud. And the 3 pillars of Go, simplicity, scalability, and community, are the reasons why many of these companies keep choosing Go. If you want to learn a bit more about who's using Go, how to get started with the language, you can visit go.dev. Finally, I wanted to touch on the community, which in many ways is the beating heart of Go. The community is what keeps Gophers active, connected, and up to date on the latest changes with Go and related tooling and support. The community also actively contributes to Go releases, helping the Go team at Google make the best decisions for the ecosystem. To get a sense of scale, today, the Gopher community has grown to reach over 180 groups in nearly 50 countries. These groups host events almost every week and are now doing so virtually. Over the last year, there have also been 32 conferences. One conference is taking place very soon. Just next week, many Gophers will be attending GopherCon in a new all-virtual experience. The Gopher community, whether it be meetups, listservs, or smaller groups of developers, are all enthusiastic and inspiring. Joining one is a great way to meet other developers, jump into Go, and share your knowledge with others. The swag is pretty cool too. So I've talked a bit about what makes Go great, where the language is heading, and who's using Go, ranging from individual devs to enterprises. I also touched on the community and how Gophers around the world stay connected and informed. Hopefully this has helped you answer the question, why Go? But to take it one step further, my colleague Steve and Carmen are going to cover the top 4 use cases for the language. These are command line applications, APIs, web apps, and DevOps. So take it away.
Go is a great fit for command line or CLI applications. Over the past decade, these have made a huge comeback and firmly have a place alongside server, web, desktop, and mobile apps. With CLI applications, there are a few factors that are really important. You want the application to seamlessly work cross-platform. You want the application to load instantly. You want it to be easily installed and updated without local dependencies. You want the app to have good performance, and you want it to be easy to write an app with good usability. Go checks every box. Go natively supports every modern operating system and architecture, and many legacy ones. Go makes it trivial to build Windows, Mac, Linux, etc. versions for various architectures right from your development machine. Most applications build around 1 second. For anyone who's used C or C++ based applications, this is unbelievably simple. Go applications have 0 dependencies on the host. There's no fighting with incompatible libraries or runtime versions, and no runtimes or interpreters to install. Once the application is built, installing it is as simple as copying a single file to another machine. It just works. Compared to Java, JavaScript, Python, Ruby, and even C-based applications, this is incredibly smooth. Upgrading is just as easy. Simply replace the old file with a new one. It's a single file. What could be easier than that? Applications written in Go benefit from instant startup times and fast performance. Unlike Java, JavaScript, Python, Ruby, etc., there's no need to load up a virtual machine or interpreter, so they're able to start instantly. Go's performance and concurrency take full advantage of modern multi-core processors to easily write applications with great performance. Are you sold yet? But wait, there's more. There's a robust ecosystem built around Go CLI applications. Go.dev lists popular libraries and books to get you started. Learn.go.dev also has a workshop on building CLIs in Go. The most popular CLI library is Cobra, which includes a generator that effectively builds your application for you, using intuitive design patterns, including subcommands, parameters, and flags. It also automatically generates help, autocompletion, and documentation. When GitHub wanted to build a new CLI, they chose Cobra and Go, and the response has been fantastic. They joined thousands of companies and projects who have built CLI apps in Go.
To understand why Go is good for DevOps, I find this quote works well. Go was not designed to be an academic language. It was meant for large production systems, to quickly onboard many inexperienced engineers to a code base, providing continuity across the software lifecycle from development to production to maintenance. This is the essence of the DevOps movement and the adoption of site reliability engineering at Google. Before going further, I'd like to briefly talk about site reliability engineering, also called SRE, and DevOps. What's the difference? DevOps and SRE are 2 trending disciplines with quite a bit of overlap. In the past, Some have called SRE a competing set of practices, but it's not so different from DevOps. To read more, visit the link at the bottom. The key thing is that DevOps and SRE are both organizational practices. Go was designed to simplify practices around developing software for the entire lifecycle. Given similar philosophies and goals, Go is clearly a match for DevOps. Let's go over 9 reasons why Go is good for DevOps and SRE. Mentioned interchangeably are all the practitioners, which include software engineers, site reliability engineers, systems administrators, operations engineers, and production engineers. As mentioned before, Go is made to be readable, designed for onboarding programmers to teams quickly. It strikes a good balance between expressiveness and brevity. Even error handling, an oft-critiqued aspect of the language, has benefits of this explicitness, as particularly for when those errors hit programs running in large production systems. A small but strong standard library. A smaller footprint makes it easy for learning, developing, and maintaining software across the stack and lifecycle without getting bogged down in choice. As mentioned in the talk on CLIs, Go has minimal runtime dependencies. If you're a systems administrator, operations, or production engineer, you don't need to worry, as all runtime libraries are included in the compiled executable. So you can distribute your app the way you would any other statically linked binary. Speaking of binaries, you don't need to worry about what version of Go is installed on your systems, or even if it is installed on your systems at all if you're an ops. This makes it easy for doing migrations, upgrades, and deploys. It's great for these types of operation tasks. Also, if you're an ops, you'll often run into the chicken-egg problem, needing dependencies installed before running tools or scripts for your infrastructure where your app lives. Go is great for this bootstrap tooling where you don't yet have your dependencies installed. Garbage collection built in means that operators don't have to be burdened with memory management, making Go both easier to use and more reliable. Easy concurrency support via Go routines. This is a first-class feature of Go and vastly simplifies distributed systems operations. Code bases today are becoming larger and larger with huge amounts of concurrency due to networking requirements that didn't exist 20 years ago. Go is the right balance of trade-offs needed to solve modern productivity issues. It's the modern-day bottleneck for running distributed systems, which isn't performance, it's human cognition. Go addresses this human cognition issue without sacrificing performance. Go is also more explicit and better glue than shell languages. Glue refers to those connector bits of code you write to put your system together. The lack of data types in Bash or PowerShell start to come apart after 100 lines. For articulating more complex scripts for your infrastructure, you'll need something strongly typed. Use Go. And finally, Go is still very performant, particularly at scale. To finish off, there's a saying that software is never done. This is equally true for development and production and maintenance. Use Go for the entire software lifecycle and implement DevOps practices into your organization to improve your system and your business.
Developers love using Go. 90% of developers prefer to use it for their next project. Web applications are one of the most popular things developers build in Go, with half of Go developers using it for web apps. Go's concurrency, speed, and excellent library support make an ideal environment for today's web applications. Today, I'm going to introduce you to Go's cloud support, database support, web security, web frameworks, and learning resources. As is common today, many web apps are hosted in the cloud. Go has first-tier support on all major cloud platforms, including Google Cloud, Amazon, Azure, and AliCloud. This includes serverless offerings like Google's App Engine and Cloud Run, and Amazon's Lambda. And as you would expect, Go has great support for databases, from relational databases to document storage like MongoDB and Elasticsearch, time series like InfluxDB, and memory storage like Redis. All have excellent support in Go, and several are written in Go. Being a web developer is hard. You need to master everything from sysops, server-side programming, client-side scripting, visual design, CSS and SQL, and all the other things listed here. Not only do these cross many paradigms and styles, but they're constantly changing. You also have to be current on the latest security trends. And even if you've done all of this perfectly, you also need to keep on top of the latest network, system, and container security. It should not come as a surprise that web applications are notorious for security vulnerabilities. Go is leading the way to better security and encryption with its secure by default approach. The latest encryption standards are written in Go, often ahead of any other language, and ship as part of the standard library. Google, Let's Encrypt, and Cloudflare are all heavy Go users for exactly this reason. Unlike other languages, Go applications don't just reuse the host operating system security libraries. For most web applications, the authors need to not only write a secure application, but also ensure that the host operating system is fully secure. With Go, the security is built right into the application, so it automatically supports the latest security standards independent of the host. Go ships with a powerful and friendly templating system. Among my favorite of its many features is the built-in sanitization. It understands HTML, CSS, JavaScript, and URIs, and automatically sanitizes any variable used in these contexts. This built-in safety prevents most cross-site scripting problems. Go comes with its own web framework built into the standard library of Go. This is the most popular web framework for Go. However, if your needs exceed what the standard library provides, there are many web frameworks readily available, and Go's modular nature of favoring composition means that Go's web frameworks and libraries all play well together. Go.dev has a book, tutorial, library, and framework recommendations to get you started. Popular web developer projects from Smashing Magazine to Vote.gov to Bootstrap to Let's Encrypt all use Go for their websites.
Let's outline why Go is great for application program interfaces, or APIs. APIs allow the capabilities of one program to be used by another, and they are essentially tools for bridging businesses in all industries. Go is a language with a formal specification, and it doesn't have undefined behavior. The API behaviors outlined in the spec can be read in under an hour. So even if you're new to Go coming from another language, you can most likely know what an API definition does in very little time. This specification or spec extends to decoding third-party or non-standard library packages. Speaking of third-party packages, Go is simple enough that if you want to find out what's really going on in some unfamiliar code base, you can. And often that's by inspecting the code itself. This simplicity allows for quick building all over the Go ecosystem. With the Go package discovery site, which you'll learn about in the Go ecosystem session, finding which packages and APIs are best for the job is easy and an almost trivial task. For those of you interested in specifics, Go is simple yet robust for containing all the primitives you need for APIs, including strings, lists, maps, and concurrency. I'd like to focus on concurrency here. Concurrency describes the concept of running several tasks at the same time, and this can either happen in a time-shared manner or parallel if you have multiple cores. For APIs, concurrent programming is a very difficult subject, but in Go, we have concurrency built right in as a first-class feature of the language. This is important for some types of high-level APIs like streams, and the native concurrency is a big deal for APIs on both the server and the client side. Right balance for all APIs. If you care about low-level or performant APIs, Go can help you with bare bones, but also is complex and heavy enough to be useful for high-level APIs, especially ones that come from object-oriented languages where everything is boxed and there's a heavy use of generics. Also, there are multiple paradigms for APIs, including REST, RPC, and GraphQL. Go maps well to encodings like JSON and protocol buffers. And the 1.0 compatibility promise meshes well with API consistency over time. In conclusion, Go is good for APIs due to simplicity, a small but strong language, for easy onboarding and compatible usage across paradigms, robust built-in functionality, particularly for concurrency, and a thoughtfully designed middle ground between systems and high-level APIs. Thanks, Matt and Steve. It was such a pleasure to create and present that together. I loved it because I learned some new things about web, which is not my forte, and also about the growth that's been happening in the ecosystem among companies and different programming use cases, which you can read about on go.dev. Steve, did you learn anything?
I did, but my favorite part of that was actually just watching the live Q&A and seeing all these great questions come in. It's something usually as speakers, we don't get a chance to interact at that level. So that was really fun, and I hope the questions keep on coming.
Yeah, we'll do our best to try to answer each and every one of them. There's so many good ones, and we want to be able to get to a lot. Behind the scenes, we're kind of sending some of the people who do know the answer, we're sending them quick chat messages and saying, hey, can you help answer this or that? So please be patient, and hopefully we'll get you an answer before the end of the show. Next up, we're going to hear from Steve Trout, our technical writer for the Go team, about Go basics and installation. Take it away, Steve.
Hey there, I'm Steve Trout. I'm a tech writer on the Go team. Today I'm going to show you how I can install Go and write a bit of code. Along the way, I'll talk about modules, which Go developers use to manage dependencies. And I'll finish up by writing a simple web service, which is one of the things Go does best. So let's get started and install Go. I'll visit the Go homepage at golang.org and click the Documents link, and then Installing Go. Now this page includes a button I can use to download a file to install from, along with installation instructions. If the download isn't what I'm looking for, I can click the other downloads link to scroll for a file that might be a better fit for me. But I'm going to click the great big button to download a file to install. And once it's downloaded, I'll open it to start the installer. All right, and click continue. And it's telling me how much space Go will take up on my disk after I've installed. I'll click install. And it prompts me for my password. And then the installer begins running scripts to install Go. This takes about a minute or so. It's downloading files from the Go site to my computer, and it's running scripts to update paths on my computer so that I can run Go commands from the command line. And once it's finished, Go is installed. I'll be using the command line for this demo, but there are several editors and IDEs that support Go. If you like an IDE, be sure to check out the talk by Julie Q and Rebecca Stambler. So in my command prompt, I'll run the Go version command to confirm that Go is installed. The output tells me Go's release version along with the OS it's compiled for. And now I'm ready to write some code. I'll start with a Hello World app. First, I'll create a directory in which to keep the code. And I'll cd in there. And then I'll create a file to put the code in. Today I'm using Sublime Text. So I'll save it into the directory I just created and call it hello.go. All right, so all Go code needs to be part of a package. A package is the primary group in which you organize the functions you write. So I'll declare a package first. I'm calling this package main because any Go code you want to execute on its own has to be in a main package, and I want this to run independently. Writing an executable program in Go is easy. There's a specific convention that Go follows. Create a package called main and put a main function in it. In a main package, a main function becomes your application's entry point. So I'll create a main function. All right, so next I'll import the fumped package. Fumped is short for format. The fumped package contains functions for reading and printing text, and it's just one of more than 300 packages in the Go standard library. I'll be using a function in the fumped package to print my greeting. So inside my main function, I'll call fumped println. So Go has great support for great native support for Unicode. So I'll get a little bit clever here. Instead of using text for my greeting, I'll grab a couple of emojis and paste them into my code and use those. This looks like a hello wave. And looking for the world. There it is. Copy that. And paste that in as well. So this should be all the code I need. The quickest way to run Go code in a simple setup like this without an IDE is to use the go run command. So I'll type go run hello.go. And it's an emoji hello world. I'll make it a little bit more interesting in a minute. But first I want to say a bit more about a couple of the things I just introduced. You saw me use the go run command to run a main function in a main package. Earlier, I used the go version command to confirm that Go is installed. Those are just two of many Go commands that you might find handy. Here are just a few more. You could run go build and go install to compile your code to a local binary. You can run go test to test your code with Go's testing framework. And go get is a commonly used command to download source for your code's dependencies. I'll show that later when I use code someone else has written. For the full reference on commands, check out the golang.org website, where the commands are organized according to the things you might want to do. I also want to say more about how Go code is organized and distributed. You write code as functions, and you collect related functions into packages, and you collect related packages into modules. If you want to make your functions available to other developers, you publish your module so that it's visible on the package discovery site. As a Go developer, you have access to lots of other packages and functions you can use in your own code. That includes the hundreds of packages in the Go standard library. Those are listed on the package discovery site at package.go.dev. But you can get even more packages written by other developers. Their packages are available alongside the standard library. You can search for a package you might want to use. Packages for adding features related to databases, security, encryption, and so on. Right now, I just want to show you how you can use a package you've found. So I'll search for one I already know about. I'll look for the quote package. And this RSCIO quote package is the one I'm looking for. So that quote package was written by Russ Cox, one of Go's designers. I know Russ does good work, so I'm going to give that one a try in my code. From the list of functions in the package, I can see he's got a hello function that returns a friendly greeting. And here at the top of the page, I can see that Russ's package is in a module called RSCIO /quote. On the versions tab here, I can see a list of the versions for this package in the module. Each of these represents a tagged version of the code in Russ's repository. Go modules use the semantic versioning model. A version number includes a major part, a minor part, and a patch part. A major update includes changes that aren't guaranteed to be backward compatible. Those might be changes to the module's public API, for example, things that break code that's already using the module. A minor version update is guaranteed to be backward compatible, but it also could include changes to the public API, such as adding new functions. A patch update is guaranteed to be backward compatible and is for bug fixes. So let's look again at the V1 versions. Let's look again at the V1 versions. V100 had a single function in it. V110 is a minor release, so it added another function without breaking backward compatibility. And it was the same for V120, which added a third. V121 is a patch release, so no changes to the public API, but it's a bug fix release. And down here, V2 and V3 are major version updates that don't guarantee backward compatibility. This versioning scheme helps you keep your code stable. You can upgrade in a deliberate way, knowing the risk. So now I'll try out the package. I'll copy the package path up here at the top of the page. And now I've got it so I can paste it into my own code in an import statement. And import rscio quote. All right, and in my main function, I'll call Russ's quote hello function. I'll replace what I'm doing there with the emojis and add a call to hello. All right, so now I'll put my code into its own module. Having it in a module gives me a way to manage its dependencies, like this quote module I just added. I'll show you how in a minute. I'll add my code to a new module by running the go mod init command. And for the command's argument, I'll give it a location in my Git repository, because that's where I'll eventually keep my code. This becomes my module path, and it's part of a unique identifier for my module. And now I'll run the command. So the command created a go.mod file. Let's take a look at that. The file gives the version of Go I'm using as the minimum required version for my module. Also at the top there's that Git repository location, and that's now my module path. If I decide to publish my module for other developers to use, that module path is how Go will find my code to download it when they need it for compiling. For example, I'm now importing the quote package, but I don't yet have the package's code to compile with. To get it, I'll run go get, that go command I mentioned earlier. So Go went looking for source for the packages I'm importing. The command downloaded the latest version of Russ's quote module, which for V1 is 152. It also made a change to my go.mod file. The file includes this require directive down at the bottom now, and that directive says that my module requires the quote module at a minimum version of 152. Now I'll run my code again. All right, so that's Russ's hello function printing hello world. So this is a common sequence in Go. You start some code and create a module. If you need it, you find a useful package, and then you run go get to get source code to build with. The go.mod file helps me manage my dependencies. In that require directive, if I change the quote module's minimum version to 150, Go will downgrade the dependency. It's the same for upgrading. So I got Go installed and I got hello world running. I put my code in a module and I started using an external package. I'll finish up by showing one of the things Go does best. I'll make a hello world idea and turn it into a web service. Web-based apps are some of the easiest to build with Go. That includes HTTP servers and web services. I'll change my code so that when someone makes a call to a specific URL, I'll return JSON with the hello world greeting in 3 languages. I'll start by declaring a struct to hold the response data. A struct is a collection of fields, so it gives me a way to group together my greeting text, the language, and a language code. Notice those string literals in the text, the green text there. Those are called struct tags. Each one specifies the JSON field name that will be used in the output, the response value. That gives me a way to ensure that generated JSON fields have lowercase names. Otherwise, Go would use the struct field names, which are capitalized. In Go, you capitalize a field or function name when you want it to be visible outside the package it's in. In this case, the Go code outside my package that creates JSON from my struct needs access it can only have if the field name is capitalized. Lowercase field and function names aren't visible outside the package. Next, I'll declare a slice to hold the multiple greetings. A slice is a Go array whose size changes as I add and remove items. This slice gives me a way to collect multiple structs, one for each language. Now I need a function to do something when the requests come over HTTP. So I will add a handler. I'm adding a hello handler function whose parameters represent the request and the response I'll create. Both the response writer and the request type are part of the HTTP package that's in the Go standard library. The HTTP package is one of the reasons it's so easy to write web services in Go. It includes functions for making requests over HTTP methods, handling responses and headers, and other low-level aspects of HTTP. Check out the talk by Julie Q and Rebecca Stambler for more about using the package to set up a web server. Inside the handler function, my handler function encodes the contents of the greeting slice into JSON for use as a response. To do that, it uses an encoder type from the JSON package, which is also included in the standard library. And I'm using setIndent to set an indent string, so the response is a little bit nicer to look at. Before I finish the code, I want to mention the := operator I'm using here. You use it to declare a variable and assign it a value in one line of code. You don't need to declare the variable's type. Go figures that out for you. I like it because it's a great example of how Go's design keeps things simple and uncluttered. Now to put it all together so the service starts when I run the code, I'll update my main function and replace what I was doing before with this. So I'm calling handleFunc to map a URL path to the handler function I just wrote. When a request comes in on /hello, the hello handler function will be used to handle the request. Then I'll call listen and serve to start a server that listens on port 8080. Ordinarily, listen and serve just starts and runs without returning a value, but if it returns an error, I want to handle that. The fatal function will, in the standard library's log package, will log the error and exit. Now I'll run the code. Go run, hello.go. Okay, so apparently I'm not quite finished yet. It looks like this command's output tells me that I'm importing 2 packages that I'm not using and trying to use 3 packages that I'm not importing. So I'm importing fumpt and rscio quote and not using them, and I'm trying to use HTTP, JSON, and log. So let's take a look at the code here. Here's where I'm commenting fumpt and quote. So I need to update my imports to account for that. So let's fix that by pasting in some new imports. I'm going to combine the imports into a block using a single import statement. This is something I could have done earlier. I just didn't. So now I'll try to run the code again. I feel a little bit better about it this time. Okay, so the service is now running. I'll open another command prompt to try it out. and I will curl localhost 8080. Hello. All right, it looks like it's working now. So I've got JSON, a snippet of JSON with my hello world messages in 3 languages. And I got this going by using only packages from Go standard library. There are external packages that have more web service features and might be as easy to use. If I wanted, I could find those using the package discovery site. So that's all I have to show today. You can find lots more about Go at golang.org, go.dev, and all over the web. If you're interested in support for Go in editors and IDEs, as well as Go's package discovery tools, be sure to check out the talk by Julie Q and Rebecca Stambler. Thanks for watching.
Hi, welcome back. Steve, thanks so much for sharing that. Watching that video really brought me back to when I was first learning Go many years ago and the good experience I had with it. My favorite part was I looked in the Q&A part and there was a participant, Alexander, who during your talk was able to download, install, and write his first Go program, all while you were teaching. That's so inspiring. Carmen, when you first started Go, what were some of your good and challenging experiences?
What I really liked GoFunked. Coming from Python and Ruby, I wrestled a lot with linting code. And I just was tired of spaces versus tabs argument. And I think that GoLint is a simple but production booster for Go programmers. You import that library and you run GoFunked before you compile, and it just automatically does everything for you. So that tooling that just came right in as part of the installation was great. I think also I like the little things that Steve mentioned, the short variable declarator that understands the type and also initializes. These are the little things that just kind of made Go, just for me, a pleasant experience, got things, some of the like more friction-based things out of the way.
That's great, and what a nice transition, because we're about to hear from Julie and Rebecca, who are going to share with us more about Go tooling and more about Go discovery and how you can find out all the great libraries across the Go ecosystem. As always, put questions in the Q&A forum. Not like it feels like no one needs to be reminded that the forum is so active, but we do want to answer every one of these questions. So if you have a question, please ask it and start getting excited for the after party. And Julie and Rebecca, handing off to you.
Hi everyone, I'm Julie. I work on the Go team with Rebecca, and today we're going to show you how to build a Go web application with the help of the Go package discovery site and your Go editor tools. If you don't already have Go installed on your computer, you can do so at the link shown on the screen. If you need help, you can check out the video of Steve's Getting Started with Go session from earlier today. In this session, we're going to start by showing you how to set up your editor for Go development.
Thanks, Julie. Hi, everyone. I'm Rebecca, and I work on the Go team. One of the great things about Go is that the Go team provides backend tooling that plugs into many of the popular text editors, like VS Code, Vim, Emacs, and Sublime. For today's tutorial, we'll use VS Code. However, all of the features that we show you today are available in those other editors too. So we'll begin by creating our project. You can find this code on GitHub at the URL in the demo. We're going to run go mod init to create a module, which you saw earlier in Steve's presentation. So now let's open our module in VS Code. Here is the go mod file that is created by running go mod init. You can see here. And you can see that I've already installed the Go extension, which you'll need for coding with Go. And you can install it by searching for Go in the extensions pane. So next, we'll create our Go program by creating a main.go file. And since we're using modules, the extension will prompt us to install the language server, Go Please. So this is the editor backend that I mentioned earlier. Go Please works in all editors to provide an IDE-like experience for Go, especially with Go modules. And so once we install it, we'll be able to use the various IDE-like features like completion to create our package and our main program. And now once we're done with that, we'll be ready to start coding.
So now that our editors are set up, let's go ahead and build something. As Steve mentioned in the Intro to Go session this morning, web applications are one of the most popular things that developers like to build in Go. So we're going to do that today. I'll start by sharing with you one of my favorite things, which is this turkey chili recipe. I've been making this recipe all year and I have it saved on my computer in a markdown file. But what I would really like to have is a nicer UI to read this recipe and other recipes in my collection. So today we're going to build a web app which reads this markdown file, converts it into HTML, and renders it in our browser. That way we'll have an easy way to browse all of our favorite recipes. And as a first step to building our web app, let's read the markdown file and print the contents of that file to our terminal. So in the module that Rebecca just created, I'm going to create a directory called static, and I'll copy the markdown file and image for that recipe into this folder. There are tons of packages that are part of the Go standard library and included when you install Go. In Steve's Getting Started with Go session earlier, he showed us how to use the fumped package. I'm going to use another package from the standard library called IOUtil. So let's check out this package on the Go Discovery site, which lives at pkg.go.dev. The Go Discovery site is a website with information about Go packages that you might want to discover, evaluate, and integrate into your modules. I want to give you a preview of some features that are going to be coming soon. So in this tutorial, I'm actually going to be working off a new version of the site that will be live in the next few weeks. I'm going to start by going to our search bar over here and looking up the IOUtil package. And as we can see from the package documentation, IOUtil implements some IO utility functions. In this tutorial, we're going to use the read file function to read our markdown file from disk and then print it into the terminal. So let's go ahead and look for the read file function in this index and click on it. This will take us straight to the function, and from here I can see the function signature, a description of how to use the function, and an example. So let's open up the example and go ahead and copy it so that we can then build off of it in our editor.
Now let's start writing some code. Let's create a web server to present our turkey chili recipe. In the same module that we created earlier, we're going to add a helper function to load a page by reading this turkey chili recipe file from disk. I'll just paste in the code that Julie copied from the IOUtil package earlier, and I'll put it into our load page helper. You'll remember that Steve manually updated import statements in the earlier talk, but when I save the file, the editor will automatically format my code and it will add all of the necessary imports to the top of my file. Finally, we'll just clean up the code a little bit to match our helper function's signature. So now that we've read the file, we can actually begin building out the web app. You can build a web server in Go using only the standard library with the net HTTP package. So we're going to start by exploring that package. I'm not necessarily sure of which function I will need to use, but I know that I want to register code to run an HTTP handler. So I can just start off by typing the HTTP package and triggering autocomplete. I'll immediately see a bunch of symbols related to handlers, and I can figure out which one to choose by reading the documentation that pops up on the side here. I think that handle func is the one that I want because it lets me create a handler with a single function. So that's the one that I'm going to pick. But I still want a little bit more information about how to use handle func. Fortunately, when I hover over the function, I'll see a link to the discovery site, package.go.dev. When I click on it, I get taken to the documentation for handle func in the net HTTP package. And here we have not just documentation, but another example. So we can open up this example and we can use our same trick from earlier and just copy and paste this code directly into our editor. So this is all the code that it takes to write a basic web server in Go. Let's modify it to use our load page helper function that will read our recipe file. We'll start off by validating the user inputs in the URL. Make sure they typed in the right thing. They're looking for the turkey chili recipe. And then we're going to call the load page function to print out the file content. Next, we'll add some logic to handle any errors that may occur while we're reading the file. And you'll notice that the completion is designed to search all of the available symbols in the workspace. So you don't even have to type HTTP dot to get that internal server error completion. You can just start writing out the word internal, because that's what you know what you're looking for. And then finally, we'll just format the content as an HTML template so that we can actually render it on the web page. Now, let's run the server and see how it looks. Not too bad, we got something going, but the formatting isn't very readable. It would be really nice if we could actually render that markdown as HTML. So the standard library has gotten us really far. We've made an entire web app, but unfortunately, the standard library doesn't have a markdown parser. So Julie, how can I go find one?
We can use the Go package discovery site to search for third-party packages that we might want to use. So I'm going to go to the discovery site and type in Markdown into the search box. And look, there are a lot of results. This first one here is Black Friday. And if we take a look at it, it seems to be pretty popular based off the imported by count. So let's go ahead and click into that one and take a look. So on this page, I see a banner that tells me there's a newer V2 version. I'm going to go ahead and use this V2 package instead. And I can see on this page that the V2 version seems to have less importers than the V1, which is likely why it was ranked lower in search. I want to figure out how to use Black Friday. So let's take a look at the README. From the README, I see this installation section. And so I'm going to click Expand, which is right underneath it. There are instructions here on how to go get and import this package. And if I look through the README a little bit more and go ahead and scroll down on this page, I see that Black Friday is currently maintained and the recommended version is V2. So we're looking at the right version now. The package documentation is also a useful place to look for information, and we can access it from the left side nav. This overview tells me that Black Friday is a markdown processor, and the other description here is that it tells me the simplest way to invoke Black Friday is to go ahead and call the run function. So I'm going to go to this jump to identifier box here and search for run. And so this brings up the run function and I can click on it, which will take me straight to that identifier. I can see the function signature, the description, and this description here tells me that all I need to do to use Black Friday is to pass in an input and then I'll get back an HTML output. So I think that this package is worth trying out. So I'm going to go to my header and click this copy button to get the import path onto my clipboard. Rebecca, how about we go ahead and give Black Friday a try in our editor?
Thanks for finding a markdown parser, Julie. Now let's go ahead and use it. So we're going to run a go get command to add Black Friday to our module and to our local module cache. Immediately you'll see that my project's go.mod file is modified to add new dependencies. And also immediately, the editor will show me that these dependencies are not yet used in our module, which is expected. We haven't used the Black Friday package yet. But now that the package is in our module cache, the editor can provide auto-completion and other support for it. So let's go ahead and use Black Friday in our module. When I type out Black Friday, the editor will offer me multiple options, since there are multiple versions available. But Julie suggested that we should use V2, so let's pick that one. And Julie also suggested that we should use the run function to parse the markdown, so we'll use that one as well. And finally, we'll just make some minor modifications to the code to return an HTML template, since that's what we need to render the markdown as HTML. And now it's time to try running our code once again. Awesome, the turkey chili recipe showed up, but I'm not sure if it's rendering totally correctly. There's still something off about those emojis at the top, and also our table doesn't look much like a table. Julie, do you think there's an issue with this Markdown file?
Let's take a closer look and see how to evaluate a third-party Go package. It seems like the things that are broken on this page are the table and the emojis. And I know I followed the spec for GitHub Flavor Markdown, but maybe there's an issue with how Black Friday is parsing my Markdown file. Let's go ahead and look at the documentation for Black Friday again. I'm going to search for GitHub Flavor Markdown this page, and let's see if anything comes up. Oh, and look, it takes me right to this section, and it tells me that Black Friday is structured to allow alternative rendering engines, but GitHub Flavor Markdown isn't supported right out of the box. What about emojis? Let's search for that on the page. It looks like nothing is coming up, but if I go and click this repository link to go and look at the project, I can browse around on the issue tracker and see if anything comes up there. So let's go to the issue tracker, search for the word emoji, and see if anything comes up related to emoji support. So there's this closed issue here, and if I click on it and click through this issue and look through the top, and maybe I'm going to scroll to the bottom here and see if there's a resolution. It seems like what this is telling me is that Black Friday is compatible with this other third-party package that provides emoji support, but it doesn't have it integrated directly. So Black Friday could still be a great package to use, but I'm kind of curious to know if there's something else that would fit my use case better. So how about we go ahead and revisit the search results that we had for Markdown before. So on this page, I see that the second result in this list is something called Go Markdown. In this case, this package doesn't have a tagged v1 version, and so it might not necessarily be stable. I don't really want to pull this package into my project just yet in case this breaks something later on. There's this other project here, Goldmark, though, that looks promising. It has over 100 importers, and there's a v1 release. Let's click through it and see what this project is like. So from this page, I can immediately see that the latest version of Goldmark was published pretty recently. And if I go and click on the version history, I see that there's a pretty consistent history of maintenance for this project. Going back to the main page, let's look through the README and see what that says. I'm going to look for GitHub Flavor Markdown support again. And right at the top here, it tells me that Goldmark is easy to extend and there are extensions provided for GitHub Flavor Markdown. If I scroll through this README a little bit more, I see the other features here, one of which being that it's really easily extensible. And if I look through the usage section, it provides me examples of how to use that code and code snippets that I can use to pull stuff into my code. Okay, Rebecca, I think we have enough information here. Do you want to go and give Goldmark a try?
Sounds good. Let's switch out Black Friday for Goldmark. We're going to start off by downloading the Goldmark package. But it might be easier if I extracted a helper function to do the Markdown rendering, and then I modified that. So I'm going to highlight the area that I want to extract and click Extract to Function. The editor will refactor the code for me, and all I have to do is rename the function to something a little bit more useful, maybe something like render markdown. And then finally, we'll replace all of the code in the render markdown function to be the code that uses Goldmark. So I'll just paste that in, and then we're ready to go. Let's try running our server one last time. Awesome, looks exactly as we expected. We have our turkey emojis at the top, and we have our formatted table.
Well, our package is ready for use, and we had pushed it to GitHub, and the code is open source. So I would really love to see this package in the Go Discovery site. Let's go ahead and add it. So while we're on our project's GitHub page, let's add a pkg.go.dev prefix to the URL so that we can see this package on the Discovery site. You'll notice our package isn't here yet, but I can go ahead and click this request button, and that will request for the package to be downloaded. And there it is. We can see our README, we can see the documentation, and then if we look in the header here, we can see an imports link, and clicking on that shows us all the packages that we've been importing into our package. If we then click on source files on the left-hand side, this takes us to the bottom of the page, and here's the file that Rebecca has been editing this whole time in VS Code. We can click on it, and it'll take us to the actual code repository. And here's all the code that we've been working on during today's tutorial. But it would be really nice though if when users stumbled upon our package on GitHub, they knew that they could also look at our package documentation on the Go Discovery site. So the Go Discovery site actually provides a badge exactly for this use case. We can generate a badge and then put it in our README, and then when people see our README, they'll know to click on it. So let's go to pkg.go.dev/badge. And we can put the module path into this input box. I'll go back to the project page and copy the URL and then paste it right here. This will then generate code snippets for me. So there's one for HTML and one for Markdown. I'm going to click to copy the one for Markdown and add that to my clipboard. And then I'll go back to our repository and go and edit the README file and put this code snippet into the top of our README file. And if I click the Preview Changes button, I'll see that there's a badge now at the top of our README file. And anybody comes across it and clicks on this badge, they'll be taken straight to our project page on the Go Discovery site.
So our demo code is public, but so are the tools that we use today. The code bases for the Go Package Discovery site and the Go Editor tools are also open source. If you want to contribute to these Go projects, you can find them at the links on the screen.
You can also find the package that I've been working on in this tutorial right on the Go Discovery site at this URL. Thank you for joining us today. And if you have any questions, feel free to reach out to us on Twitter.
Thanks, Rebecca and Julie. That should give you a good understanding of the details of how package discovery and editor integration all come together for a great Go experience. I hope you all found that as useful as I do. To learn more, you can visit the Go documentation pages at golang.org/doc. If you're a GCP or Google Cloud customer, check out shell.cloud.google.com, which is a cloud editor with VS Code baked in and all the Go integrations, including debugger support. Last, but certainly not least, we're excited to welcome Steve Kaufman from Khan Academy to tell us why and how his team migrated to Go and what benefits they're seeing from the transition. This is the third Steve that we have in this Go Open Source Live Day. What do you think, Steve?
I think if we could get all Steves at the next conference, that would be maybe the best conference ever. We call it Steve Con.
Steve Con. I'm down for it. Steve Con. Well, thank you for being a part of Google Steve at Google Open Source Live. And now for Steve Kaufman, we're all ears.
Hi, I'm Steve Kaufman, and I work at Khan Academy. And today, I'd like to tell you how Khan Academy is saving both time and money by transitioning from Python to Go. First, what is Khan Academy? At Khan Academy, we believe it doesn't matter where you start. What matters is where you go. By offering a free, world-class education for anyone, anywhere, we're leveling the playing field, one learner at a time. Just last year, millions of people spent 8.7 billion minutes actively learning at Khan Academy. Now, who am I, if you'll pardon the brief digression? I've been a software engineer for 20 years, and I've worked at Khan Academy for the past year. In my career, I've found that I've grown the most professionally when I work with people with diverse experiences. I love the diversity of experience that I have seen at Khan, and I'm proud that Khan is committed to further increasing that diversity. One other thing I love about Khan is on the anniversary of our first day, it's a tradition for us to give back. This year, I collected information on all the best remote home office setups for all those who are newly working from home. I always enjoy this kind of quirky, personal gifts that we give to show our appreciation to one another. And now I want to show you how Khan Academy engineers are shepherding us through a remarkable transformation, which will hopefully be invisible externally, just to show how much I appreciate the work of the rest of the organization. First, where did we start? We started on GCP App Engine. And we started with a Python 2 monolith. And this served us well for much of the company's history. Where are we going? Well, we're going to GCP App Engine still. But we're also going to multiple Go services, 27. And we're going to use GraphQL in between the services. So, as you may have heard, there's been an end-of-life announcement for Python 2. And when that came out, it forced us to make some choices. We chose Go. It was fast, which translates to cheaper. It's got a rich ecosystem and a rich standard library. It's simple and productive, and maintaining someone else's code is a pleasure in Golang. I've maintained code and I've written my own code in many different languages over my career. I love the expressivity of writing code. I love doing some clever little trick and doing all these other kinds of things, switching from one paradigm to another, experimenting with things and playing with them. It's a true joy. But the problem is that when I'm maintaining somebody else's code, the cleverness that they put into their code sometimes makes my head hurt. Sometimes I look at their code and I have no idea what this is doing and what the context of the original decision was, especially as it's shifted over time. People switch from one paradigm to another, back and forth. When I maintain somebody else's code in Golang, it's a pleasure because it looks just like my code. I love that. It may be grumpy at first, but I really love the maintainability of Go. It's so simple, it's so easy for anybody to jump into a code base and makes perfect sense to them. We also had to choose what platform we should run on. We chose App Engine, again. We wanted to avoid undifferentiated heavy lifting. Many organizations get a little too caught up in their own creations, and their own sort of creations end up owning them, as they have to have a burden for maintaining something unique that the rest of the ecosystem doesn't know anything about. If there are common problems with common solutions, it's easier for us to focus on our own business value than to try to actually have to make some other unique solution. The other thing about App Engine is that it scales great. When COVID-19 forced school closures across the world, we really had almost nothing to talk about because everything just scaled pretty much amazingly. We had a few secondary systems that weren't user visible that we had to make some tweaks to, but no real problems to speak of, which I think speaks volumes to the reliability of App Engine. I should actually say even more about that. Our PagerDuty is all volunteer. And the reason why we can choose to let everybody opt out of that and have to opt in is because it goes off so rarely after hours. It has only gone off, it's less than once a month for the past year and a half. And it's continuing to go off increasingly rarely in the off hours. And every time it has gone off, it's been our fault. It's not been Google's. So App Engine's pretty great. I highly recommend it. The other choice we had was, should we stick with the monolith or switch to services? We chose services. Try to imagine an entire family, all living, working, and going to school in the same small living space. I know, it's so far-fetched, but bear with me. We have 86 engineers at Khan Academy, and in our monolith, it started to feel similarly cramped. Borderless engineering required intense thoughtfulness, discipline, and coordination to avoid bumping into one another. Our deploy queues got longer and longer, as we needed to test all the things for even a small change. We also couldn't isolate how much specific efforts cost compared to the benefit they brought, to know whether we were spending our resources wisely, or whether we should choose another path. We also needed to choose how should services communicate between one another. We chose GraphQL for this. We had great success previously with React and GraphQL on the front end. App Engine, as awesome as it is, unfortunately does not support HTTP2 gRPC yet. But GraphQL provided a ubiquitous language across Go and JavaScript divide and across the back-end front-end divide, so that all of our engineers could actually have a very similar experience when they were at least talking about those contracts. Speaking of those contracts, by having our GraphQL be schema-driven and then generate the code from those schemas, we didn't have to get tangled up in expensive contract testing, because we knew that those were exactly what we had written. We wrote the spec first as the contract, and then the code just got generated from that. We also had to decide how should we divide up into services from our monolith. It's a little messy to put them all in here, but I wanted to illustrate the point that we chose not to make our services very micro-sized. Wherever there seemed to be a good conceptual or technical seam, that's where we drew a line. A few are not directly user-facing. For instance, we have an email service. That's not pictured here. But some, like the static asset requests, go through fastly and then straight to Google Cloud Storage. What have we learned when we transitioned to Go? And how did we learn those things? So, a lot of our developers, most of our developers, were not familiar with Go in the beginning. So we collaborated and created a tiny little command line app that was all test-driven. And then we deleted all the code, leaving only the tests. We had developers who had never seen Go before be able to actually, one by one, enable the tests and make them pass, and move on until they had a fully functional application that would forecast the weather. Not exactly trivial, but not exactly complicated. It was enough to give them a taste for the language, and it was enough that they, in true Con style, were able to take those and try to get hints and get if they had any sort of issues, and it would actually work out pretty well. We also had encouraged our developers to read and to practice using Learn Go with tests, which is an excellent resource. After that, we engaged with Arden Labs to have them provide training on site to our engineers and remote for all those people who are remote. One of the big lessons that we learned is to create a cookbook for everything that's confusing. When somebody asks the same question more than once, to listen to that as a signal. And we've written how to do different things in Go, how to do different things in GraphQL, how to translate certain paradigms from Python into Go, and we maintain that over time. Whenever somebody is new, they are the most valuable resource in looking at that, because any confusion that they find, that's a signal that we use to help to improve that resource and make that a living resource as we move on. The other thing that we're doing is we're actually open sourcing some of our ongoing onboarding. We have an open source repository, the web workshop, that we're trying to develop in order to allow ongoing education for any new developer that comes on to be able to come up to speed reasonably quickly. When you're making a drastic shift, such as from a Python service to a Go service, or from a monolith to services, you need to make sure that that transition can happen in a safe manner. The way that that has traditionally been done is using a technique such as traffic shadowing, where requests go to the new version and the old version, but only the response from the old version is given to end users. And you only compare those, and once you feel confident, then you can shift over to being able to provide the end user with the response from the new version. GitHub pioneered a similar technique using the library scientist to be able to make those sorts of transitions inside of a code base. that same technique has been ported to many other languages and other frameworks. We were inspired by that. But we at Khan Academy chose to do side-by-side testing, where we're using GraphQL Federation to allow us to transition at the granularity of even a single field at a time within our GraphQL. So this is what our side-by-side transition looks like at Khan. We develop in the Python monolith first. We make sure that we're actually using the GraphQL endpoint and not taking advantage of the fact that we're in the Python monolith to make a library call. Then we start to develop a Go service. After we deploy that Go service, we end up actually making a request that goes both to Python and to Go. But the Python response is the only one that goes back to the end user. The Go is secondary here, and its response is only used to record discrepancies, and then it's discarded. After we're confident that that has no more discrepancies in it, we then make Go primary, and its response is the one that the end user sees. Python's response is now discarded, and then we transition to Go only and delete the Python code. So in our side-by-side, we start out with the Python monolith, then we develop in a Go service, then we have Python as primary, where Go's responses are secondary and discarded, only used for comparison's sake, to warn us if there's a discrepancy. Then we switch to having Go be primary, and Python as secondary, where the Python's responses are now the ones that are discarded. Then we can delete the Python code and have Go only serving this. It's code time. So the GraphQL schema that we end up changing, here we have this created date field that's already defined in Python. And we'll hit an error if we try to also define it in the assignments Go service. But until we define this field, we can't generate a GQLGen model or write any tests. To get around this issue, we add the migrate directive to our field with the state set to manual. This will allow assignment service to define the created date, but will hide the field from the normal schema. If an end user requests this field, the gateway will continue to fetch it from Python, but will not make any requests for it from Go. Once the implementation of this field is done, we can enable side-by-side testing by setting the migrate directive state to side-by-side. Here, now, both Python and Go are getting the requests for that field. When they are both providing it, every request will be examined for differences, both locally and in production. A developer locally will receive instant feedback that there's a discrepancy as they go through either unit tests, integration tests, or just click around on the site locally. In production, we can see over millions of requests if there are corner cases where the fields might differ. Remembering to first make a Python set deterministically ordered is probably our most common mistake, even if it's not really apparent to a user. In production, we can also look for patterns in the discrepancies in many ways. In case there's an edge case that, for instance, only occurs at a particular time of day. I'm not going to go through all the different ways that our SREs are able to slice and dice this to identify unusual patterns, but just suffice it to say that we have a lot of great metrics, and they bring that to the developer's attention. So now our schema changes, and we can now ignore the Python value of the field and pass the one from Go. We support this state to make it easier to stage deploys and to reduce the risk of rollbacks. We also use this state as we are transitioning to having all the GraphQL traffic move through the gateway. It may be that some clients, mobile native for example, may not yet be able to query through the gateway, and so we may need to keep a field defined in Python to satisfy those requests. Once we're happy with the Go service serving traffic for this field in production, we can remove the definition and the related code from Python. Once we do that step, we can remove the migrate directive entirely. This field is now just a normal GraphQL field like any other. So, now engineers are happy and productive in Go, our efficiency went up, our costs are bending down. what's next? Right now, we have 34.5% of production traffic served by Go. And as we kind of expected, it's been sort of following a normal curve. And right now, we're seeing an acceleration in the code that's being transitioned to be solely served by Go. We've also adopted a new policy where we're trying to share as much as we can open source by default. Before, we were much more concerned with only putting out open source code that we were committed to maintaining. But we realized that there's a missed opportunity. Sometimes the community could benefit from some of the choices that we've made without necessarily having us to devote a large percentage of our engineering staff to be able to maintain that to meet all the possible end user use cases. We're still open to collaborating, but we might not, in all cases, pursue all the different use cases that the community is interested in. We're also going to try to share our onboarding process. We're developing some of our individual tools, like the web workshop and the forecast app, as open source. And we hope that as we onboard new developers who are unfamiliar with Go or our environment, that will be beneficial to them as well as other members of the community. So, I hope that this was useful to you, and I hope that you found this story to be compelling. I certainly can highly recommend Khan Academy as an excellent place to work. And if you're in the market, feel free to drop us a line. Thanks. Any questions?
What a terrific use case. It's easy to see why Steve was so excited to share how Go has changed how he and his team work and how they could serve as many students as possible. In the chat, we saw a lot of people asking how they could get more involved or find out more about Go. The best place for information is the Go Twitter account, which is at GoLang. There you can find out about things like our currently running Go survey. The Go user survey helps shape the future of Go, and we invite everyone to participate in it. You can also find out how to get more involved with conferences and other community events, and you can find out about our upcoming birthday. And with that, it's a wrap. Now it's time for the after party hosted by our own Van Riper, someone who many of you may know through his community efforts.
We have an updated Google Meet link to join the after party. Please look for a button in the agenda page. Today's speakers will also be joining, and we'll have some quizzes, interactive activities, and surprise guests. We hope to see you all there. And with that, we leave you with Go's 10th birthday celebration video from last year. Thank you, and wherever in the world you are, we hope you write in Go.
Have a happy birthday. Have a happy birthday. Happy birthday, a very happy birthday to you. Happy birthday, Go!
Happy birthday, Go!
Happy birthday, Go!
Happy birthday, Go! Happy birthday, Go!
Happy birthday, Go!
Good guys.
Happy
birthday, Go! Happy birthday, Go! Happy birthday!
Happy birthday, Go! Happy birthday, Go!
Happy birthday, Go!
Happy birthday, Go!
What's up, Go?